Now let's suppose an experiment consists of tossing a coin 3 times and observing the sequence of heads and tails. Since I want to observe the sequence, that tells me that order counts. So first thing I want to do is I want to determine my sample space. We're going to write this out in green. So what's my sample space? Well, a nice thing to know might be to kind of figure out what the size of our sample space is going to be. So I need to figure out how many choices there are for my first term, my first coin, second coin, and third coin. So if we think back to chapter 5, the outcomes that I get from my first coin flip, there's only 2 of them, right? There's heads or tails. Same thing for my second, same thing for my third. So I should have 8 total outcomes. So I'm going to see, okay, what would happen if I got all heads? Then I could get heads, heads, tails, heads, tails, heads. And then tails, heads, heads. So these are the 3 options where I could get exactly 2 heads. Next, I could have all tails. I could have tail, tail, head, tail, and tail, head, tail, tail. And this is our 8 possible outcomes. So I want to, I want to determine E sub 1, where that's the event that there's exactly 2 heads. What does that look like? Well, it's going to contain these 3 elements right here. I don't know what I was trying to do there. You guys kind of circled them. It's going to contain these, right? Each of these has exactly 2 heads. So I have HHT, HTH, and THH. Next, if I have event F that's 0 tails, which of these elements has 0 tails? Well, there's only one. I'll write it in orange. So I have F equals heads, heads, heads. So I just wanted you guys to notice that an event can have one outcome or multiple outcomes. It kind of depends on how the event is defined. So let us be a sample space of an experiment, right? The event corresponding to the empty set is called an impossible event, right? It's an event that can never occur. For example, if I asked you to roll a 6-sided die and my event was you roll an 8, 8 is not on a 6-sided die. That would be an impossible event. The event corresponding to the sample space itself, S, is called the certain event because the outcome must be in S. So let's say I have you roll a die and my event is you must get at least a 1. So that would mean if you get something at least 1, you get 1. And then it includes anything greater than 1. Well, I skipped 5. Isn't this the entire sample space S when rolling a die? So that's an example of a certain event. Remember from chapter 5 when we talked about set theory, right? We had unions and intersections and complements of sets. The same thing holds true for events, right? We kind of want to think of these events and our sample space as sets. So if 2 events occur precisely when either E or F both occurs, that's going to be the union. Event E intersect F occurs when both E and F occur. And the complement of an event, right, occurs, that'd be E prime, occurs when E does not occur, right? Going back to our definitions of sets. So, for the experiment of rolling 2 dice, let's let E sub 1 be the sum of 2 numbers that is greater than 9, and E3 be the numbers of the 2 dice are equal. So I already found E sub 1, but I don't have E sub 3. E sub 3 is the numbers on the 2 dice are equal. So why don't we go ahead and write that guy? Well, E sub 3 is going to be 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6, right? If the dice are equal, that's just rolling a doubles. That's a 1, I swear. Okay, so now I want to know the union of E1 and E3. Remember, union means I take everything in E1 and everything in E3, but I don't repeat the duplicates. So for example, where these two overlap, I don't know why all my parentheses went away. Sorry, gang. What elements occur twice? Darn it. Now I've seen the answer. Oh, now I saw it again. I'm trying to change pen colors and it's just not happening. Okay, so let's see where these overlap, right? I see that both of them have a 5, 5, and both E3 and E1 have a 6, 6. So this is their intersection, right? But first thing I want to talk about is their union. Okay, so I'm going to take all the elements in E3 and all the elements in E1, but if it already occurs, I'm not going to repeat it. So I have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and then I have 4, 6, 5, 6, 6, 4, and 6, 5. Now I want to look at the intersection. The intersection is when both events occur. Well, they both occur here and here, right? This is where both the sum of the numbers is greater than 9 and the numbers on the two dice are equal. So there we have our intersection. And here's our answer. But you want to make sure you got parentheses and brackets. I don't know why those stuff didn't copy, guys. I will figure it out and make sure it is correct in the PDF, but I'm not going to waste my time putting in a bunch of parentheses right now.